So I know that from my flow chart, I know that my rule is going to be a Greek prefix, the nonmetals, first nonmetals name, second word, Greek prefix, the nonmetal stem name for the second one, and then it'll end in "ide." Greek prefix, nonmetal one, then another Greek prefix, the stem name for nonmetal two, and then "ide." My Greek prefix, the first one here is "died." If you forget what the Greek prefixes numbers are, you can always look those up on your chart. But "die" is 2, and I can see that the first nonmetal is hydrogen. Hydrogen is an H. So I know that I have 2 hydrogens. The second word here, mono, tells me that the subscript would be a 1, right? But we don't write the subscript if it's a 1. We'll just leave it, right? Because the 1 is assumed. We see that the ox here, right? That's the stem name for oxygen. Oxygen. So we'll write in our O. And of course it ends with "ide" because that's part of the rule. All right, so the IUPAC systematic name for, this is H2O, white water. You guys drink this every day. And the chemical name, the systematic name for this compound is dihydrogen monoxide. All right, so if you want to creep somebody out today, tell them I need a nice tall glass of dihydrogen monoxide. Let's see, the next one that we have on our list is, so here we got potassium nitride. So the first thing, of course, we've got to ask ourselves, is it ionic? Is it covalent? Or is it an acid? Does this one end in acid, like our acids do? No, I got somebody shaking their head, right? So it doesn't end in acid. So it's not an acid. And do we see any Greek prefixes? Any Greek prefixes in this name? Any monos, di, tri, penta, hepta, right? We don't see any of those either. Right? So if we don't see any Greek prefixes, right, we know that in our covalent compounds, even if the first word, right, doesn't have a Greek prefix in front of it, the second word must have some Greek prefix in front of it if we're looking at a covalent compound. All right, I think I see someone typing. All right. All right, somebody got it right on the head, right? That's ionic. All right, we don't see any Greek prefixes here. So this is going to be ionic. All right, good job, Christina. So if this is ionic, that means that our naming rule is that we have the name of the cation followed by the name of the anion. So I'm going to need to go find this cation on my chart and this cation on my chart so that I know which letters to put in my formula. I'm also going to have to do some crisscrossing here so that I make sure that I have the right subscripts. So I'm going to pull up my periodic table of ions. I printed these out because I was tired of going back and forth in Schoology. And we can see that for potassium, right? Potassium we know already is an element, right? And its ion's name is also potassium. So the ion for potassium is K plus or K1 plus. So we'll go ahead and put K plus or K1 plus. Both of them are correct. I usually just put a plus, right? Because we of course know that that one is assumed. I smudged a little bit. And I'm looking for nitride. Nitride. That kind of sounds like nitrogen, but let me check. So I know nitrogen is over here. And boom, I see that the name for the ion for nitrogen is called nitride. So that's it, right? This ion here, N3 minus. Cool. Now we have to crisscross. So of course the magnitude, this 1 on my cation's charge, is going to crisscross and it'll become the subscript on my nitrogen. But if it's a 1, do I write the subscript 1? No, I'm not going to write the subscript 1. So I'm going to just leave it blank. Then the 3, the magnitude of the charge on my nitrogen, is going to crisscross down to become the subscript on my cation, my K here. All right, I've done my crisscross. Right. Oh, I need to remember to check and make sure this is the simplified charge ratio. I've got a 1 and a 3. So that's simplified, right? I can't reduce that anymore. So my crisscross is okay that I did. Now I can put it all together. So the formula for this compound potassium nitride is K3N. We're not going to write the subscript on that 1. Oops, I smudged some more. And then I scratched up the paper. Okay. Let's see. Oh, this one is copper sulfate. It says copper 2 sulfate, excuse me, copper 2 sulfate, right? That 2 is important. So the first thing we've got to ask ourselves, remember, is what type of naming rule, what type of compound this is, so we can go based on the right naming rule. If it's ionic, covalent, or an acid. Once again, right, I don't see acid after the name of this compound, so this is not an acid. All right. And I also don't see any Greek prefixes, right? No di, tri, penta, deca, anything like that. So this is not covalent either. I know that this is going to be ionic, and there's one big thing giving this away as ionic, and that's this right here, right? These Roman numerals. So we're not going to see these Roman numerals in covalent compounds because to indicate number in covalent compounds, we use Greek prefixes. For ionic compounds, when there's more than one ion for a particular element, we end up indicating it with Roman numerals. So for this one, I'm going to need to go look up, right, my cation is this first part here, copper 2, and then sulfate is my anion. So copper 2, I need my periodic table of ions. And I can see that copper 2 is going to be the 2 plus for its charge, copper 2 plus. For sulfate, now sulfate is not sulfur, right? If we look at the sulfur, the name of that anion is sulfide. So sulfate is actually a polyatomic ion. If you are in Schoology and you're looking at the periodic table of ions, The second page of that document is the polyatomic ion chart. This is where we're going to find sulfate. The sulfate is this ion right here, SO4 2 minus. And I can see here that the charges, the magnitude of the charge on the copper and the charge on the sulfate are both 2. They're the same. What I'm going to have to do here is to reduce the charge ratio. Ratio. There we go. And basically what this means is that kind of like a fraction, it's like having 2 over 4, right? Both the 2 and the 4 are divisible by a number, 2, such that we could reduce the fraction down, right? Like in math. Same thing works here, but for the magnitudes of these charges, right, since they're both 2, we could reduce these down, right? 2 is divisible by 2. So we could reduce this down to 1 and 1. And this is just for going forward in our crisscross rule. So now we can crisscross, now that the charge ratio has been reduced. We're going to crisscross the 1 on the copper down to the subscript on our sulfate, SO4. You can see that because it's going to be a 1, we don't need to write it in, and therefore we don't need parentheses. We don't need to write in the subscript of a 1 outside of our sulfate. Therefore, we don't need parentheses around the sulfate. There's been a lot of questions about when do I use the parentheses and when do I not use the parentheses. So you'll have to use the parentheses if the number that you're bringing down behind a polyatomic ion is going to be a number other than 1. So if this had been a 2, I would have to bring this down and put it in parentheses to put the 2 on the outside. But it's a 1, so I don't have to write it. Same thing for my sulfate. Its magnitude here, 1, is going to crisscross down to become the 1 on my copper as a subscript. Of course, I don't have to write that. So when I put it together, I have CuSO4. And that is my finished formula for copper 2 sulfate. I finished a page here. Oops, let me zoom out a little bit. All right, so I've finished a page here. I want to stop and ask if there are any questions about these 3 examples before I keep moving. I'm going to do a few more. The fourth one I have for you guys is tetraphosphorus decoxide. That's a name right there, right? Sounds like a Harry Potter spell. Tetraphosphorus RUS decoxide, so CO. First thing, of course, we've got to ask ourselves, are we looking at an ionic, covalent, or acid compound? Well, I can see here that it's not an acid, right? It doesn't end with acid like our acids do. And to remind ourselves of the rule I wrote on the very front, we're never going to use Greek prefixes for ionic compounds. Never, never, never. We'll put some sparklies over that. So I see Greek prefixes, tetra and dec, right? This is deca with the A dropped off of it. That means that this is not, it cannot be an ionic compound. This must be covalent. Okay. Well, we know our naming rule for our covalent compounds, right? Greek prefix, then the nonmetal, the first nonmetal, its name. The second word is a Greek prefix. Then the stem name of the second nonmetal, followed by "-ide". I can match my Greek prefix and my nonmetal here, right? So I know that the first part of the formula is going to be the nonmetal phosphorus. Its symbol is P. Tetra, the Greek prefix tetra, if you ever forget what your Greek prefixes are or what the numbers are that they mean, you can always go back to your flow chart and take a look at your Greek prefixes here. But tetra is 4, so that'll be my subscript on the phosphorus. That's the first part of the name. For the second part of the name, I've got another Greek prefix. So I know that whatever nonmetal I have here, I have 10 of them, right? DEC, dec. I can see that the stem name here is ox. If you ever forget, so going back in Schoology, if you ever forget what your sorry, there was a bell. If you ever forget what your stem names are, you can always go back to for reference and check out those stem names. But ox goes with oxygen. And the Greek prefix tells us that we're gonna have 10 of those oxygens. So this is the chemical formula for tetraphosphorus decoxide. Right, the I just is the ending that we have to have on the end. Let's try an acid. So number 5 that I have here is dichromic acid. Of course, we can ask ourselves that first question, right? Is this an ionic, covalent, or acid compound? But we can tell by the name right away that we're dealing with an acid. If it says acid on the end, we're looking at an acid. But if we recall, there were 3 different acid naming rules. There was one if the ending of the anion was "-ide". There was a second one if it ended in "-ate". And there was a third one if it ended in "-ite". Remember, if it ended in "-ide", of course, if you forget, you can always go back to your chart and check out your rules here. But if it ended in "-ide", we would have hydro in the front and it would end in "-ic acid. But I see "-ic acid, I don't see a hydro in the front here. So I'm not dealing with my "-ide" rules. I see that if it ended in "-ite", I would have the stem name and then "-us" acid. But this is an "-ic acid, not "-us" acid. So I know that it's not "-ite". So it has to be "-ate". "-ate" has to be the ending. Okay. I know from my rule that it's stem name followed by "-ic acid. That means that everything other than the "-ic acid So this dichrome part is my stem name. To get back the name of the anion, I just have to use the correct anion name ending, which we found out was 8. Dichromate. I'm going to need to find dichromate on my polyatomic ion chart. Right, dichromate is not going to be on the periodic table of ions. We're going to have to locate it on the polyatomic ion chart. So dichromate is here. Right, and that's Cr2O7, and the charge is 2-. All right, we're going to hold on to that charge because we need to use it for something. Cr2O7, 2-. So you don't have to understand a whole lot about how acids work at this time, because we're going to talk about them more in Unit 7 and then in even more detail in Unit 8. But one thing about acids that we talked about is that they have that hydrogen in front of them, right? That was like our dead giveaway, that the hydrogen in front told us that we were looking at an acidic compound. So acids are special. One of the things that they'll do is they'll ionize in water, which means that the compound, the acid itself, will break apart into 2 ions. The ion that we see for hydrogen is a hydrogen 1+. So we're going to see hydrogen 1+ or hydrogen plus a lot. We're going to see this hydrogen 1+ or this hydrogen plus a lot. All right. So remember this because we're going to need it in order to crisscross to write the formula for our acid. So it's going to work the same way that our ionic compounds do because these ionize. Of course, we've got our magnitudes of our charges. We're going to have to crisscross here. Crisscross. My charge ratios are already nice and reduced. So I'm going to crisscross. This 1 would become the subscript on my my dichromate anion, Cr2O7. And you can see that because it's a 1, I'm not going to have to write the subscript, so no need for parentheses or anything. And then I'm going to crisscross my 2, the subscript 2, or excuse me, the charge, the magnitude of the charge on the anion, down to become the subscript on my cation. I'm just going to bring this all together to rewrite it a little bit clearer. H2, Cr2, O7. So this is the formula for my dichromic acid. Leave that one there for a sec. This was a little bit different than what we've done before. It's kind of the same concept that we're applying to our ionic compounds over to our acids. I do want to stop at this time, though, and ask if anybody has a question or if they would like to see another writing the formula of an acid from the name. Move forward. I think we're okay with that one. So we're going to switch gears. We're going to now start naming the compound from the formula. So I've got this acid here. It starts with an H, so I know it's an acid. So it's HMnO4. Right. Of course, I know that this is an acid, right? It's got the H in the front. But I've got different acid naming rules, so I have to think about which one I need to use. Does it end in "ide," "ate," or "ite" with the name of the anion? So I'm going to look for the anion MnO4 on my chart. And it is here. MnO4 minus, or 1 minus. That's called permanganate. Permanganate. All right, so everything excluding the H and its possible subscript is our anion. This one's called permanganate. So 8, of course, ends in, or excuse me, permanganate, of course, ends in 8. So these are the rules we'll be using. And if we can recall those rules, if we ever forget, right, I remember by saying I ate something icky, so I know that it's going to end in ic acid. Kind of a quick way. But of course, you always have access to your chart to be able to look and see, okay, if it ends in 8, then I'm going to put stem name followed by ic acid. Another bell, another bell. Oh my God. Okay. So that means that I'm going to drop the 8 off of my anion so that I can get my stem name. So if I remove the 8, I would have permangan. And then to here, I'm going to add on the ic acid. So the name of this compound is permanganic acid. Let's see. Our next one up is H2CO3. All right, we're looking at another acid because we've got that H in the front. All right, and so for this acid, of course, it's got that H in the front. We've got to think about what our naming rule is going to be. All right, does the anion, so the CO3 here, everything except for the H and its subscript is our anion. So does it end in "ide," "ate," or "ite"? All right, I'm going to go pull this up on my polyatomic ion chart. And I can see it up here towards the top. All right, carbonate in this middle column here. Carbonate up towards the top is CO3, 2 minus. So that's carbonate. So carbonate ends in 8. We'll be using the 8 rules. And that was that we're going to have the stem name followed by ic acid. All right, just like the last one. We'll drop the 8 off of the ending to get our stem name, carbon. And then we'll add on ic acid. So the full name of this compound is carbonic acid. I don't see anything in the chat. Let me check on your mind. Yes. Okay. All right. The next one we've got up is K3N. This should look familiar because we just wrote K3N from its name. So we're going backwards now. Got to ask ourselves, is this ionic, covalent, or an acid? I can tell right away that this isn't an acid because I don't have hydrogen in the front. If from here you're wondering, okay, how do I tell what kind of compound it is, ionic or covalent, right? Check on the chart. Formula did not begin with an H. And the formula actually consists of one metal and one nonmetal. We're looking at a formula that does not only have two nonmetals, it actually has one metal and one nonmetal. Potassium is a metal and nitrogen is a nonmetal. I had a question last class. Somebody asked me if we have a metal and a metalloid. Right, so if you've got like one metal and then one metalloid, for example, like silicon or boron, or what's another one? I think germanium is one, right? So if you're seeing one metal and one metalloid, the metalloid is effectively a non-metal. That means we're looking at ionic bonding or ionic, an ionic compound. I was asked if we had one non-metal and one metalloid. Are we looking at what kind of bonding or compound are we looking at? Metalloid. Right, effectively the metalloid is a non-metal. So once again, if you have just the two non-metals, then you're going to be looking at a covalent compound. I thought that was a really good question because that was something that we hadn't discussed explicitly. But here we're looking at a metal and a non-metal, so this is ionic. The format we'll follow is cation name followed by the anion name. The name of this cation, if we pull it off of our chart, is going to be potassium. Oops, I'm going to write the K again. And the anion, right, is N, that's nitride. So this is potassium nitride. Let's see, we've got, like 8 minutes left. Yes, I should be able to finish out these last two. Right, but once again, if you need me to stop on one, please do stop me. Okay. The next one we're looking at is called barium, or it has barium in it, so it's Ba3N2. I've had some students, if you're ever unsure of an element, like barium, for example, is not one that we see all the time. If you're unsure if it's a metal or a non-metal, check on it, right? Go to your periodic table. On my periodic table, I have all of my groups blocked off, and I have barium down here, element number 56. And we can see it's over here on this side of our periodic table, right, with all of our metals. All right, barium is actually in group 2, our alkali earth metals. So barium is a metal, but nitrogen is a non-metal. So when we ask ourselves, are we looking at ionic, covalent? Once again, it's not an acid. All right, don't see an H in front. But we are looking at one metal and one nonmetal. So this is going to be ionic. This Ba here from our periodic table of ions, we can see that the name of that ion is barium, same as the name of the element. And we're putting the cation first, followed by the anion. And the anion here is N for nitride, N3 minus. And you can see how that would have looked crisscrossed, right? Barium was the 2 plus, and that 2 was crisscrossing down here. Nitride had a 3 minus, and that 3 is crisscrossing down to this subscript. So you can see how that compound was made there. This is barium nitride. Right. No Greek prefixes. Last one. All right, the last one we have is P507. I wonder if any of these, some of these might come up in the assessment. I can't remember. That would be handy, huh? First question we've got to ask ourselves, are we looking at ionic, covalent, or an acid? Well, it's not an acid. There's no H in the front. When it comes to covalent or ionic, we've got to ask ourselves, does the formula consist of only those two nonmetals? In this case, phosphorus and oxygen, right? They're both on the kind of far right side of our periodic table here, phosphorus and oxygen. So these are both nonmetals. That means we're looking at two nonmetals only. So this will be covalent. Now we have to name it. Our format, of course, was Greek prefix, then the first nonmetal's full name, another Greek prefix, the stem name of our second nonmetal, and we end with "ide." The Greek prefix for 5 is penta, like a pentagon. The name of the nonmetal, P, that's phosphorus, PHOSPHORUS. The second Greek prefix is going to go with this 7 here. All right, if you forget what it is, check your chart, your flow chart. That's going to be hepta for us. Now I'm going to write hept because I don't feel like erasing again. We'll see that we're going to fill in the stem name of the second nonmetal, which is oxygen. Oxygen is going to have the stem name ox, right? Which is why I've dropped off the A from hept. If you take another look at your naming rules, you'll see that the second note here tells you that the letter in parentheses on our Greek prefix is going to be dropped in certain instances. And those instances occur when the stem name of the second nonmetal starts with a vowel. So for example, oxygen, right? Ox. So we don't want to put heptaox. We're just going to put heptox. And then we'll have our ending "ide." So the full name here is pentaphosphorus heptoxide. I've got a couple more examples here. I can zoom out, get those all on the page.